Assalamu alaikum rahmatullahi barakatuhu. Subject Computer Science for 12th Standard A section. In this session, we are going to start a new unit number 4, database concept and MySQL. So, last class we completed chapter number 10 and unit number 3. Now, we are going to start the new lesson, unit 4 and chapter number 11, database concept. In this session, we are going to discuss the following topics. So, data, information, database, DBMS, database structure, data model, different types of DBMS and RDBMS, types of relationship, relational algebra in DBMS. First introduction, we should understand what is a database. Database is a place where we store the data in a large amount in an organized manner electronically to access and retrieve data and store data, edit data whenever we require. So, of course, data plays a very major role in our life, day-to-day life. We require a lot of data. So, based upon the data and their validity and their truthfulness, the information are obtained by processing the data, and by using the information we made conclusions, we made decisions. So database is a place where we store data in electronical forms. So next point is discuss about the database term used to refer for two things in day-to-day life which was not correct but we use. So database is a place where we store data, but sometimes database is oftenly used casually to refer the software also, that is the DBMS. So database is also used to refer to any of the DBMS software. DBMS means database management system. So it is a category of software which is used to create databases. There are many number of softwares in this category, that is DBMS category, to store data in form of databases. So technically we can understand what is database. So database is a place where you store data, a large amount of data, electronical form, and these data can be stored, manipulated, accessed, and they can be taken as a report by using the DBMS software. So database term is also used to refer DBMS software, but it is not correct practice. So we know what the difference between database and DBMS. So database is the place where we store data. DBMS is the category of software which is used to create databases in computer system. So manually, if you look at the your school class register is a very good example for database where we store names in alphabetic order, where we store different data related to student like father name, annual income, community, address, phone number, pan card number, passbook number, Aadhaar number, other related data whichever school requests. All the data are stored in a single register. That register is the best example for databases. These data are used for future use. Now we are going to discuss the important terms which regularly used in databases. First word is term. First word is data. What is data? Data are raw facts stored in a computer. Of course, a fact is a truth. Raw fact means in truth there should not be any process. A truth without any process. So a data may contain any character, text, word or a number. Some of the example of database is 6006, DPA Campus, SCRT, Chennai College Road. So here you can see in example, six number of data are listed here, five number of data are listed here. Number one, 6006, it is a number. DPA campus, it is a character. SCRT, it is a word or any expansion. Chennai, it is also a text. College Road, it is also text. So when you see this data separately, you cannot understand what is did. But when you process this data in a proper manner by using DBMS softwares, you may convert this data into a useful information, useful data, what is called information. So information is a formatted data or processed data which allows to be utilized in a significant way. For example, SCRT College Road DPA Campus 6006, it is the address of a technical institute of education department, SCRT. So College Road, DPA Campus, and Chennai 6006. So, as you see from the example above, data appear as a set of words and numbers. However, when the data is processed, organized, and formatted, it gives a meaningful information. That it gives a address of the SCRT. So this is what we actually do in DBMS software. We store data separately and we process the data in a correct manner, and we obtain the new data called information. This information is known as processed data. So next one is database. So database is a place where we store data in a repository collection of related data in an organized way. The data can be easily accessed, managed, and updated. So, of course, we know database is a place where we store data, but the whichever data we store in any database, that data, each and every data should be related to one another. If there is no relationship, then you cannot create information. For example, if you take this database, when 6006 is the pin code of Chennai area, if you change it as a 635802, then there is no relationship between this pin code and the Chennai, because 635802 is the pin code of Ambur. When you change this pin code, then there is no relationship between this data, and without this unrelated data, when you process the data, we get only the false information. For example, if you write the address SCRT College Road DBA Campus Chennai 635802, it means there is no pin code like 635802 in Chennai. So it is a false information. It is a false address. So this is the simple example to understand this database. So database is a place where we store repository collection of related data in a organized way for accessing, managing, updating the data. Database can be a software or hardware based with one sole purpose of storing data. Next one is DBMS. Database Management System is a software allows us to create, define, manipulate database, allowing user to store, process, analyze data easily through interface, or a tool also provide protection and security to the database. So database is a place where we store the repository collection of related data, and these databases can be created by using DBMS is a software category which provide many tools for creating, manipulating, updating these databases. So these databases can be created by using DBMS, and they can be protected by this DBMS. So giving protection and security to the database is also a responsibility of the DBMS. Some of the DBMS are Foxpro and DBase. These examples are very old. Now we are going to see a new example called MySQL MS Access, which is also we're going to learn in this upcoming topic. Now we are going to understand the characteristics of your DBMS. So of course we know data DBMS, the expansion of the DBMS is database management system. So it is a software. That software should satisfy these following characteristics, then only by using the DBMS we can create a effective database. So first character is data stored in tables. Whatever data we store by using DBMS should be in a format called tables. All the data should be stored in the format called tables. So of course tables are made up of rows and columns. So by using the rows and columns format only we can store the data in DBMS. And by using these rows and columns only we can create the relationship between data in DBMS. Next one, reduced redundancy. Redundancy means duplication of data. In modern world, the cost of hard drives are very cheaper, but in older days, early days, the hard drives are very expensive. So in DBMS, which provide redundancy, it means the duplication of data is called a loser database because it cannot provide a effective or optimize use of hardwares. So unwanted duplicate data will create complexity as well as create a very big problem in cost of the project. So the modern days DPMS will provide you the facility called reduced redundancy. Redundancy means duplication of data are reduced here, but now also we used to duplicate data, but in a very little manner where we required. Next one is the data consistency. Data consistency means it is called the constants, the accuracy of the data. In online data management, the data consistency is very important and it should be updated and added maintained with the effective manner. But this data consistency can be achieved through nowadays database management softwares. So data consistency means if you take an example, a live cricket match result, a live election result, or any live song which we play through any app. So this is called the live accessing the data from internet from any other data through DBMS software. So if you see the data consistency are well maintained by this DBMS. Now we are going to see the next characteristics of DBMS called support multiple users and concurrent access. So nowadays DBMS allows multiple users to access a database simultaneously in a concurrent way. It means in a single time many users can access the DBMS. Next, query language. Query is a type of question which can be accessed, which can be sent to any database by using a special language called a query language. The query languages plays a very vital role in DBMS. So these query languages are very simple and used to fetch, insert, delete, and update databases. Without knowing the query language, we cannot handle the databases through DBMS. So query language are very important language like C++ language which we'll learn in the upcoming topics. Next one is the security. Of course, DBMS also provides security because it provide multi-user support multiple user access and concurrent access. So whenever the databases are accessed by many user can change many updation concurrently. So security also plays a very important role in DBMS. When an unauthorized person access that databases and if the important data are hacked, then it creates a very big issue in real life. So security is also a very important characteristics of the DBMS which also provided by DBMS softwares. Next, support transactions. So it allows us to better handle and manage data integrity in real world application where multi-threading is extensively used. So we can support DBMS support transaction. We can do many transactions simultaneously at a time in the databases through DBMS. Next one is the advantages of DBMS. Segregation of application program. It means all the application programs are segregated in a effective manner to give its best. Next, minimal data duplication or data redundancy. Easy retrieval of data using query language, reduced development time and maintenance. These four important advantages of DBMS. Next, components of DBMS. There are five important components in DBMS. Number one, hardware. Two, software. Three, data. Four, procedures or methods. Five, database access language. We will see one by one. The first component of DBMS is hardware. Hardware is any device which is used for database. It may be hardware, hard disk, it may be input output devices, it may be input output cable or infrared or Wi-Fi. Whatever we use for connecting the input output devices to system for accessing the database are called hardware in DBMS. Next one, the software which used to control the database software, DBMS software. So, and the DBMS software is capable of understanding the database access language and interprets into database commands for execution. So, by using software tool only, we can give commands to database by using the database access language. Third one is the data. It is that the resource for which data DBMS is designed. So, the main purpose of the DBMS is storing the data in a correct manner. So next one is the procedure or methods. They are general instruction to use a database management system as installation of DBMS management system to take up backups, report generation, etc. So this is a fourth component of DBMS which is used to take backups of databases and report or the generation of databases. Fifth component of DBMS is database access language. Of course, you know the SQL language is the famous language used for accessing the database software and also used to give insert command, update command, delete command for any database. These languages are called SQL, and some of the example for DBMS is DBase, FoxPro, which we already discussed. Now we are going to see the database structure. Of course, we know all the data in database should be stored in the form of tables. We know tables are made up of rows and columns, but in database we should not use the word row and columns. They are called with another term called tuple or attribute. In database, all the rows are called tuple, all the columns are called attributes, and all the tables are called relation. So we should not use the row or column words. The alternative for the row word is tuple. So why we call tuple? Of course, we know tuple is a type of database, the data type where we store many type of data with different data types. So of course, each and every tuple shows a data of related each other. So and each and every attribute shows a piece of data of a complete data record. So if you take any tuple, you can see a complete record of any person. So these are the three important terms which we use in database. So the attribute is the alternative name for column and tuple is the alternative name for row. It may be called as record because tuple shows a complete record of a person. Attribute shows a piece of record, piece of data of any table. Table can be called as relation in database structure. Next one is data model. What is data model? Data model describes how the data can be represented and accessed from software after complete implementation. It is simple abstraction of complex whole data getting. So there are five important data models are used for storing data in databases and also the software methods for accessing the data within the databases. The main purpose of data model is to give an idea as how the final system or software will look like after development is completed. So the famous five data models are hierarchical model, relational model, network database model, ER model or entity relationship model. The last model is object model. We will discuss one by one. The first model is hierarchical model. It was developed by IBM as information management system. It is represented as a simple tree-like structure. This model represents a one-to-many relationship, that is parent-child relationship. One child can have only one parent, but one parent can have many children. This model is based on this concept. This model is mainly used in IBM mainstream. So here you can see the different tables of a single database called school. Consider school is a database where we store different datas and their datas can be stored in different tables or instance. So school provide courses, school provide resources. Courses comes can be divided into theory and can be divided into lab. So all the group of data can be grouped into a different categories and they comes under single database called school. So this is called the one to many relationship, that is parent child relationship. So one parent may have many children, but one child cannot have many parents. This is called the tree like structure pattern. Next one is the relational model. This model was first proposed by EF Code in 1970. It is mostly used in nowadays the one of the successful model of database. The basic structure of data is relational model is tables. All the information related to a particular type is stored in for rows of that table. Hence, tables are also known as relations in relational model. And relational key is an attribute which uniquely identifies a particular tuple. So here you can see there are two tables. One contains student ID, name, age. Another contains student subject ID, name, teacher. And each and every tuple are identified by a particular tuple key called relation key. So relation key, here key refers to attribute or column. So key is also a word or term used to refer a column in a table in relational model, or we can use the attribute also. So each and every table must have a one or more keys or columns or attribute to relate with other tables or relation. These column or keys or attribute are called relational keys in the relational model. So this one is a very successful model which we use in a nowadays. Now we are going to discuss the next model called network model. In network model, it is the extended form of hierarchical database. The difference is in hierarchical model, a child record has only one parent, but in network model, a child may have many parent nodes. It represents that data in many to many relationship. See here, the same database called school consists of many tables, library, office, staff room, and another one a new table called student. So these student can be accessed library, office, and staff room data. So this is called the network model. So simply we can say hierarchy model is like a tree like model where parent child relationships the concept is used, but in network model same parent child relationship is used, but here many to many relationship concept was used. It means many children's one parent may have many children's, many all children can have many parents. So see here, school have many children like library, office staff, and student. But student is also a node which have many parent like library, office, and staff room. So this is called network model. Next one is ER model or entity relationship model. It was created by dividing the object to entities. A new concept was introduced by Chen in 1976. Here, a new term was used called entity. It is very simple and easy design logical view of data. The developer can easily understand the system by looking at ER model constructed. So here rectangle represent entities, ellipse represent attributes, and diamond symbol represent the relationship. The only thing we can understand this is rectangle is the symbol which shows the name of the table. Ellipse is the symbol which shows the name of the keys or attributes or columns. Diamond is the symbol used the relationship. Consider two table, namely doctor, another one is patient. Doctor table consists of two columns, one is ID name. In the same way, patient table may also have ID and name. Both the tables, doctor and patient, are related by a new relationship called diagnosis. So here in ER model, we use the symbols for representing the table, rows, columns, and relationship. So rectangle symbol is used to represent entity or table. Ellipses are represent to attributes of entity or table. Diamond symbol are represent the relationship of a ER diagram. Now we are going to see the next last model of network model, object model. Object model stores the data in the form of objects, attributes and methods, classes and inheritance. So of course we discussed the OOPS concept in plus one. The same OOPS concept was implemented here in database management system. This model handles more complex application such as GIS, Geographic Information System, scientific experiment, engineering design and manufacturing. It is used in file management system. It represents real world objects, attributes and behavior. An example of object model is shape, circle, rectangle and triangle are all objects in this model. Circle has the attribute radius, rectangle has the attribute length and breadth, triangle has the attribute base and height. The objects circle, rectangle, triangle inherit from the object called shape. So when you look the object shape, circle, rectangle individually, then you can say they are different. But when you compare all their purposes and their views, then they are all comes under a single object called shapes. So circle, triangle, rectangle are all comes under a single object category called shapes. This is the concept used in object model. Now we are going to see the types of DBMS user. So there are two or three DBMS users. We will see one by one. Number one, database administrator or DBA is the one who manages the complete database management system. Takes care of the security of the DBMS, managing the license keys, managing the user accounts. Second user is the application programmer or software developer. This user group is involved in developing, designing the parts of DBMS. Third user is end user. All modern application, web mobile stores use data. Applications are programmed in a such a way that they collect user data and store the data on DBMS system running on their server. End user are the one who store, retrieve, update daily data. Actually, end user is the person who access the DBMS for solving its solving his problems. Their DBMS database administrator is the person who store the data, who give the security to the database, and application or programmer users are the user who develop the application, who develop the softwares. Last one, the database designer are the responsible for identifying the data to be stored in the database, for choosing appropriate structure to represent and store the data. So here you can see there are four number of users in DBMS. One is the administrator responsible for storing data and security. Second is the developer user, so programmer or software who develop the software or programs. Third one is the end user who use the database to store data and to retrieve the data and to solve his problem. Then next one is the designer user who is responsible for the choosing the correct data for that particular database. Now we are going to discuss the difference between DBMS and RDBMS. So DBMS is the older version of uh, yearly version of management system, and RDBMS is the newer version of management system. Both are used to store data and retrieve data, but with difference. The difference is first expansion. As per expansion, DBMS is the database management system, RDBMS is the relational database management system. Second category, data storage, navigational model, that is data by linked records, or the data are stored in the form of linked records. But in relational model, all the data are stored in the form of tables called rows and columns. Data redundancy exhibit. Of course, in DBMS, data redundancy are used many times, but RDBMS there is no data redundancy. Normalization not performed in DBMS because it uses data redundancy, but in RDBMS uses normalization. Normalization means checking the data and identifying the valid data and removing the unwanted data. Next, data access consume more time in DBMS, but RDBMS are faster compared to DBMS. Key and indexes are not used in DBMS, but in RDBMS they are used for relationship. Transaction management is inefficient and error prone and insecure in DBMS, but RDBMS provide efficient and secure transaction management. Distributed database not supported but supported by RDBMS. Example for DBMS is DBase, FoxPro, and SQL Server, Oracle, MySQL, MariaDB, SQLite are the examples of RDBMS. In our chapter, we are going to learn the new version of database management system called RDBMS, and we are going to learn a language called MySQL. So next topic is types of relationship. In RDBMS, there should be a relationship. That's only the differentiate between DBMS and RDBMS. So we should understand what is relationship. There are four types of relationship: one to one; two, one to many; three, many to one; four, many to many. Many to many. Number one to one relationship. One entity is related with only one another in other entity. One row in a table is linked with only one row in another table, and vice versa. For example, a student can have only one exam number. So this is called the relationship between the called one-to-one relationship. Next, one to many relationship means an entity is related to many other entities. So here entity refers to rows. One row in a table A is linked to many rows in a table B, but no row in a table B is linked to only one row in a table. For example, one department has many staffs. Like computer department have two staffs, Tamil department have two staffs, and Maths department have two staffs. But one staff cannot work in two departments. This is called one to many relationship. Second one is many to one relationship where many entities related to one. For example, a number of staff members working in one department. So many staffs work in single department is called many to one relationship. So next one is many to many relationship occurs when multiple records in a table are associated with multiple records in another table. Here record refers to row or entity or tuple. So here in example 1 you can see customers and product relationship. One customer can purchase many products. So customer can purchase various products and products can be purchased by many customer. So a single product can be purchased by different customer. A single customer can purchase many product. In the same way, in second example, you can see student and course. A student can register for many courses, and many courses can be uh, registered by single student or different student. So here you can see books and student relationship. C++ books can be accessed by more than one student, and more than one student can access the one book. So this is called many to many relationship. Now we are going to see the relational algebra in DBMS. Of course, we know algebra is a mathematical discipline which shows some theorems which are very useful in DBMS. These theorems are used in DBMS for successfully updating the data into information. It was created by Edgar F. Codd while at the IBM. It was used for modeling the data stored in relational database and defining queries on it. So this relational algebra mainly used for querying the database. Querying means questioning the database. When we ask question, then only we get the information. So we store data. We store many data in database. If you want to retrieve the information, then we should give the request of question or queries. These queries can be generated by using a relational algebra technique in a procedural query language used to query the database in SQL. Relational algebra operations are used here for questioning. Perform recursively on a relation to yield an output. The relational algebra is divided into five groups. Number one, select project, which comes under unary relation operation, and the second group is relational algebra operation from set theories called union, intersection, difference, and Cartesian product. So we will see one by one. The first we will see the unary relational operation. This select. Symbol for the select is mentioned here in the screen. General form with a relational R and a condition on the attribute of R. The select operation is used for selecting a subset with the tuples according to a given condition. So here we can create a subset of tuples. Tuples means records or rows by using a condition which can be sent through a select. See in the example, a table was created namely student with four attributes: student number, name, course, year, and they have many set of tuples called rows or records. So this student table can be queried using a relational algebra select command where we use a condition called course is equal to big data. Course is equal to big data in student. It means in course attribute, if any course namely big data is stored in that table, then show that tuples. So as a result we get a subset of tuples where all their courses are big data which can be accessed only through the relational algebra called select. So select is a relation algebra used to give query. So what is the query? Show the tuples or records where course is equal to big data. So from this table we can access only the records or tuples whose courses are big data. This is the meaning of this line. So this can be achieved through relational algebra operator. Next operator is project. Projection means eliminates all attributes of the input relation but those mentioned in the projection list. The projection method defines a relation that contains a vertical subset of relation. So by using select we can give a command to access the subset of tuples. If you want to access the attribute of the table or instant, then you can use the project where you can see the output of a particular attribute from a table. So from this table student, when you give a query using project, then it shows the particular column only, other columns are hide from the user. So table consists of four columns namely student name, student number, name, course, year. But when you pass this query project, then it will show only the course column, other columns or attributes are hide from the user. Next one is the union. This is called the set operators used in algebra. So of course we know what is union. It includes all tuples that are in table A or in B. It also eliminates duplicate. So here when you apply the union operator on both table A and B, all the records are added and display on the screen and duplicate records are eliminated. See in table 1, C1, CS1 Kannan, CS2 Kannan are the same. So only once they display, and CS2 Gauri Shankar is display on the screen. CS3 Lenin is also display on the screen, but in Lenin is available in both the table and A and B, but it was display only one on the screen. So CS4 Batmaja will display on the screen once. So union operator includes all the tuples and remove the duplicate tuples. This is the algebra operator which apply in the RDBMS. Next was the set difference. This difference is used to include all the tuples that are in A but not in B. But not in B. See, the attributes name of A has to match with the attributes name in B. See here you can see all the data. Kannan is matched with the attribute of table B, so it was removed. Lenin is also matched with the table B attribute, it also removed. But Batmaja is not matched with the second table, that's why this tuple only display on the screen as a result of A minus B set difference. Next one is the intersection. Defines a relationship consists of a set of all tuples that are in both in A and B. However, A and B must be union compatible. So union compatible means it only shows the tuples which are available in table A as well as and table B. Other tuples are eliminated. So here you can see Kannan tuple is available in both table, so display on the screen. Lenin is also available in both table, it display on the screen. So we can apply this intersection in DBMS also. Next one is the product of product or Cartesian product symbol X is used in RDBMS. Cross product is a way of combining two relations. The resulting relation contains both relation being combined. So here A into B means A times B when A relation B when a relation A and B have different attributes. This type of attributes is helpful. Here you can see in table A and table B, if you have three rows or tuples in A and two rows in table B, what will be the output? So 1 into S, 1 S, 1 into R, 1 R, 2 into S, 2 S, 2 into R, 2 R, 3 into S, 3 S, 3 into R, 3 R. So this is called the Cartesian product which we applied in the two tables, table A. So Kannan into big data, Gauri Shankar into Kannan into R language, Kannan into Python programming, Gauri Shankar into big data, Gauri Shankar into R language, Gauri Shankar into Python programming. So it is just like multiplying the two numbers of different list. So this is how we use relational algebra in RDBMS. So this is the simple introduction about the database management system concept. I hope you understand this concept. We will continue this concept in the next chapter. So this is the end of the chapter. Prepare the question answers of the all chapters completed and submit it through WhatsApp and prepare for the public examination. If you have any doubt, contact me through WhatsApp, clear all your doubts, prepare well for examination, do well in public examination. Take care. Assalamu alaikum.